Hello and welcome. Today we're going to be looking at adding and subtracting radical expressions. Starting off with the idea of, again, simplifying radical expressions with addition and subtraction. So an expression like 4 square roots of 2 plus 3 square roots of 2, we can combine using, again, the distributive property, which is really just the fancy way of saying combining like terms. Since these are both square roots of 2, again, using the distributive property, we can factor that square root of 2 out, add the 4 and 3 together, we get 7 square roots of 2. Again, I think it's much simpler. Just think about it the same way as we do when we add 4x and 3x together. They're like terms, so that's a total of 7x. Likewise, we can do the same thing with subtraction. 2 minus 5 is negative 3. So since they're both square roots of 3, we can combine those like terms. So negative 3 square roots of 3. Again, a point here that only radical expressions with the same index and the same radicand may be combined. So I have some examples of things that cannot be combined by combining like terms. 5 square roots of 3 plus 2 square roots of 2. They're both square roots, but we have a square root of 3 and a square root of 2, so they're not like terms. They cannot be combined. Or 3 square roots of 3 plus 2 cube roots of 3. So again, they're both 3 in the radicand, but this is a square root and a cube root. So again, only radical expressions with the same index and same radicand can be combined using this method. So here we have some that we'll take a look at trying, starting with 3 square roots of 24 plus the square root of 54. So looking at that one, you might say, well, they're not like terms, but we can simplify both of those radicals. Looking at that, we can simplify 3 square roots of 24. So square root of 24 reduces down as 4 and a 6. So that square root of 4 would be a 2. Multiply the 3 by 2, we get 6. So that's 6 square roots of 6. We're adding that to the square root of 54. Well, 54 is 9 times 6. So that would be 3 square roots of 6. So now they're both square roots of 6. And we end up with an answer of 6 plus 3, or 9 square roots of 6. And so that's what that equals. Now you can check that on the calculator. If you type it in exactly as it appears, 3 square roots of 24 plus the square root of 54, and hit enter, it'll give you some decimal approximation. And if you type in 9 square roots of 6, that'll give you the same decimal approximation. Now example B here. We've got 2 times the square root of 20x minus the square root of 45x. They do tell us to not worry and consider that x is going to be positive, so not worrying about whether x is positive or negative. The 20 would split up and reduce down as a 4, and then a 5x is what we can't square it. That works out well because we get a square root of 9 and a 5x. So again, being able to reduce these down is very important, seeing how to split those up into what can be square rooted and what cannot be. Of course, the square root of 4 would be a 2. Multiply that by the 2 we already have out in front, and we get 4 square roots of 5x minus 3 square roots of 5x. So you can see they're like terms. They're both square roots of 5x. 4 minus 3 would just be 1. So we simply get the square root of 5x for that one. Not really able to check that in the calculator, so just have to trust your work there. Now example C, notice it's a square root of 3 and a square root of 5. So we cannot use this property in order to add or subtract them. They're not like radicals. Sure, they're both square roots, but they have different radicands of a 3 and a 5. One cautionary point here, sometimes people get confused. They want to take a radical like the square root of 9 plus 16 and make that, split that up as the square root of 9 plus the square root of 16, or vice versa. Maybe they start on the right and they want to go to the left. So they have a little demonstration here showing how these two are not the same thing. So if we were to just add the 9 and 16 together, of course we get 25 and we get 5. So the square root of 9 plus 16 is 5. The square root of 9 plus the square root of 16, we can square root both of those. We get 3 and 4, and 3 and 4 is 7. So you can see that they're not the same. So whichever one you have, that's the one that you need to deal with. You can't switch it to the other form. So a good example there of a common error. People try to switch this as if it were the product rule instead of adding, and same goes for subtracting. Alright, so some more adding and subtracting. Now here we've got some higher indexes, so again you have to be able to reduce these down as well, and remember to write the index when working with cube roots and fourth roots. We get so used to not writing anything with square roots that sometimes we forget. We still have the 2 up front. Now 16 has a perfect cube factor of 8, and the cube root of 54, that has a perfect cube factor of 27. Notice how the leftover radical is the same for both. We get the cube root of 2 for both of those. Now back over here, cube root of 8 is 2. Multiply that by the 2 that we already have. 2 times 2 would be 4. So we get 4 cube roots of 2. The cube root of 27 is 3. 5 times 3 would be 15. So we get 15 cube roots of 2, or really minus 15 of those. And so we can just do the 4 minus the 15. We get negative 11 cube roots of 2. Again, this is completely numeric, so you could type in the original expression as it is. In the calculator will give you a nice decimal approximation for that. Type in the simplified form and it should be the same exact decimal approximation. Looking at the second example here on the right, we've got a 2 and then a cube root of x squared y squared, and then a cube root of 8x to the 5th y to the 4th. Now the first part cannot be reduced. There's nothing we can pull out of there. The exponents on the variables are all less than 3, which is our index, so we can't reduce that at all. The second part can be reduced. We can cube root 8 perfectly. We can cube root an x cubed and a y cubed. And that leaves us with an x squared and a y still inside the radical there. So we would have 2 cube root of x squared y plus 2xy and the cube root of x squared y. Now we can try to combine these. The values or factors really out in front of the cube root of x squared y aren't going to add together very nicely. So about all we can do with that is take the 2xy plus the 2 and multiply that by the cube root of x squared y. And that's really all we can do there. And so that's as good as we can get that. On our example C, notice we've got a square root of 4x cubed and a cube root of 64x to the 4th. Now we can simplify both of those, but again it is a square root and a cube root that we are dealing with. So if I start over here, I can square root a 2x squared out of the 4x cubed. That leaves me with a square root of x. And with the cube root, I can cube root 64. Oops, okay, I made a mistake here. This should be a 4. It'll become a 2 here in a minute. So I can cube root the 64, and an x cubed leaves me with a cube root of x. And that square root of 4x squared would be a 2x. Multiply that by the 5, we get 10x, and the square root of x. The cube root of 64x cubed would be 4x, so we get 12x, and the cube root of x. So again, you can see here that we can simplify that like we did, but we end up with square roots of x and cube roots of x, so we can't actually combine those using this property. Alright, here we're looking at, again, doing some adding and subtracting. We really need to work to simplify our radicals in example A here. So we can think of this as the square root of 25 times the square root of 3 on top, and just the square root of 16 in the denominator. With the second part, square root of 8 would be square root of 4 times the square root of 2, and the square root of 32 would be the square root of 16 square root of 2. So we simplify those as much as we can. We get 5 square roots of 3 in our numerator and a 4 in the denominator here. And we get 2 square roots of 2 over 4 square roots of 2. Now, different ways that you could handle this. So on the left side here we got 2 and then the 5 square roots of 3 over 4. I would probably just reduce the 2 and the 4, so that becomes 5 square roots of 3 over 2. You could also do 10 square roots of 3 over 4 and then factor the 2 out and cancel it. You would get down to 5 square roots of 3 over 2. With the second piece here, notice that those 4's would cancel out, the square roots of 2 would cancel out. We just get 2 as the result there. This 2 kind of looks like a z, so redo that. If you wanted to, again, this 2 you could think of as 4 over 2 and add to here. I don't really necessarily see the need for that since it can't be combined, but you could do that. So again, this 2 is the same as 4 over 2, and so then you could have 4 plus 5 square roots of 3 all over 2. I guess either way there I think would be fine. I don't feel that you necessarily need to go to this point with this, but you could. Looking at the second example, again we've got a bit of simplifying to be done there. So we would probably start by cube rooting those denominators, which will work out perfectly for us. So we get 10 and then a cube root of 5 over an x squared minus 3 and a cube root of 4 over x cubed. Now if we're going to actually combine these, we need a common denominator. The LCD would be x cubed, so this one would need an x in both the numerator and denominator. That gives us a numerator there of 10x in the cube root of 5 over x cubed minus 3 cube roots of 4 over x cubed. And not much combining we can do in the numerator there. We get a 10x and then a cube root of 5 minus 3 cube roots of 4. And that's really all we can do with that one. So it'll look like that. Well, thanks for watching. Hopefully this helped you see how to add and subtract some radicals. And of course we get some extra practice with simplifying those as well. So both some good skills to work on developing. And if you have any questions, feel free to ask. And again, as always, I recommend you go out and try some of these questions on your own.